Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 47 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. What I'm going to do is I'm going to teach you how to control a DC motor using the most excellent TA6586 motor controller, which is in your Sunfounder kit. Now, last week we learned how to control the motor the old school way, using a transistor. I believe we were using the S8050 transistor, and then we were turning the base current on and off using pin 9 of the Arduino and just drawing a few milliamps into that base current, but then it was switching hundreds of milliamps of current to not only control the on-off value of the motor, but we could also do a little bit of speed control in there. Last week, we also understood and learned in a circuit like that the importance of using a flyback diode to make sure that we don't burn something out when we are turning the motor on and off. And so that's kind of the old school way to do it, is to design a circuit from scratch using a transistor and then controlling the motor, controlling the high current in the motor from a very small signal coming from the Arduino. So that's what we did last week. This week, we're going to take it up a notch and we're going to use a motor controller. What's the reason for using a motor controller? Well, they've taken care of all the calculations and all the difficulty for you, and all you've got to do is just basically hook it up. Also, with using a motor controller, it makes it very easy to run the motor forward or backwards. That is, run the motor clockwise or run the motor counterclockwise. Bidirectional control of the motor, and we can still control the speed of the motor. And so that's what we are going to do today. Now, in the old days, I would design motor control circuits using transistors. Today, given how cheap these little motor controller chips are, most people just jump in and use the motor controller chip. Now, what I will say is what we're doing is completely suitable for these small motors like what is in the Sunfounder kit. If you decide to move up to larger motors, you need to look at the spec sheet, of the TA6586 motor controller and see what the maximum current is it can source, and then look at your motor that you're using and seeing what the maximum current is that motor would want to draw, and make sure that you're not connecting a motor up that could burn out your motor controller, okay? But that's a lot simpler than having to go through all the calculations with a transistor like we did last week, okay? Does that make sense? I hope it does. So let's jump in and let's figure out how we can start working with the TA6586 motor controller. So as we love to do on this channel, we're going to start over here at our sketch pad, and we are going to get out of your way, and we're going to look and see that what is it that you want to find in your kit. What is it that you want to find in your kit is you want to find this little integrated circuit here. And if you look at the top level, you have this little bag, and in this bag, it's the one that has the passive and active buzzers on it. There is this 8-pin integrated circuit. Now you can see mine doesn't have it because I've already taken it out and put it in the circuit, but this is what you want to see. Then you can come down here, and this is the schematic that we are going to hook up, and then up here this is sort of the picture of how we hook it up. But the first thing is, I don't believe in this class yet that we have looked at an integrated circuit, one of these little square things with the legs coming out. And the first thing you have to understand about an integrated circuit, like you can see that pin 1 here, pin 1 is the backward input and pin 2 is the forward input. But where is pin 1 on the integrated circuit, right? It could be this corner, this corner, this corner, or this corner. You got to make sure that you're hooking it up in the right orientation. And this is a little trick, and it is the standard for all integrated circuits that I know. And what you will see is on these integrated circuits, they always have a little divot like that. Okay, so let's go ahead and draw this chip. This chip had how many pins? 1, 2, 3, 4, and then 5, 6, 7, 8, like that. Where is pin 1? Pin 1 is always to the, when you put the notch on the pointed up, pin 1 is to the left of the notch. And so you always number things this way. 1, 2, 3, 4, you go around the horn and back up. 5, 6, 7, 8, like that. Okay, well now this one is laying over its side. So how should you put this in the circuit here? Well, it goes like this. So let me show you. You're going to put the notch to the right like this, okay? And then it's going to come over. And then you're going to have the 1, 2, 3, 4, 5, 6, 7, 8. How did those number? We'll just turn it over and look. It would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we can see that this chip has 2 inputs. It's got the backwards input, BI, and it's got the forward input, FI, and those we're going to connect to GPIO pins. Now, how do you control this thing? Well, let's look at BI, and let's look at FI, and kind of come up with a truth table. If this is low and this is low, then the motor is off. Simple enough. If the BI is low and the FI is high, then the motor is going in the forward direction. If BI is high and FI is low, then the motor is going to go in the backward direction. Okay, what's forward and what's backwards? Well, it sort of depends on which wire you have here and which wire you have here. Okay, does that make sense? I hope it does. Okay, so this is what you need to know right here. Okay, now how do you hook it up? What we are going to do is BI pin 1 is going to go to GPIO pin 2. FI is going to go to GPIO pin 9. And then pin 3 is going to go to 5 volts, and pin 4 is going to go to ground. Over here on the other side, pin 8 is going to go to one wire of the motor, and pin 5 is going to go to the other wire of the motor. Okay, one wire of the motor, the other wire of the motor. Okay, and I'll tell you, pins 7 and 8 are hooked together, so they're really the same pin, and pin 5 and 6 are hooked together, so they're the same pin. And so really you could connect it to 8 or 7 and the other one to 5 or 6, and you would get identical results. Now you also notice, I want you to also notice this 5 volts. We're going to get this 5 volts from the power module, not from the 5-volt pin on the Arduino. Why? This might draw a certain amount of current, and we don't want to burn out our Arduino, so we will use the little power module like that. Okay, does that sound good? I hope it does. I'll come over here and I will show you how we have this thing hooked up. That does not look very good. I'll show you here how we have it hooked up. Okay, just like on the schematic. And let me kind of go through it here. You guys can go back and look at the schematic. But the first thing that I want to say is, yes, we are using the little power board. What did we learn about the power board? It has a battery on it. Anytime you are using a LiPo battery, you've got to be very careful. You don't want to just take this power module and throw it back into a box of components where you might short things out. So before you put your power module away, you deactivate it by moving these jumpers to the center leads. Move this jumper to the center leads, and those are labeled as off. That way you shut those pins all the way off when you put it back in the box, and that way if for some reason this thing accidentally got turned on, you're not going to end up with a battery that could end up getting shorted in your box. But I'm going to go back and I'm going to put this back on 5 volts, which is the upper two, right? That's labeled 5 volts. And then 5 volts labeled the upper 2 there. Okay, now also make sure that you hook this up so that the minus goes to your ground rail and the positive goes to your power rail, the red. And then down here, the minus goes to the ground rail and the plus goes to the power rail. If you took this and turned it around and plugged it in over here, everything would be backwards, and that would not be good. So we don't want to do that. Okay, now what we said was, we said that we've got it with the little notch to this side. If the little notch is to that side, what pin is this? This is pin 1 right here. What did we say? Pin 1 goes to GPIO pin 10 on the Arduino. Do you see that? The yellow goes to pin 10. What is the next one? Pin 2 goes to pin 9 on the Arduino. Then pin 3 goes up to ground, and then pin 4 goes to 5 volts coming off the power module. Again, don't try to get the 5 volts from a GPIO pin. Don't try to get the 5 volts from the 5 volts on the Arduino. We are getting it from the power supply. Okay, we are getting it from the power supply. Now what we're also going to want to do always is, we need what? We need all of our grounds connected together. So we need to come over here and we need to grab a ground. We need to grab a ground. So I'm going into that Arduino ground pin, and I need to come over here and connect that to the ground rail, so that all the grounds are connected together. So the Arduino ground is connected to the power module ground, and that is connected to the ground of the chip. So you always want to have common grounds if you're using different components, like a power supply component combined with an Arduino. Okay, so we've got pins 1, 2, 3, 4 hooked up. Then we come down here to pin 5, and pin 5 just goes to either wire of the motor, and then pin 8 goes to either wire of the motor. What if you reverse these? Then you would reverse what was forward and what was backwards. And so what's forward and what's backwards depends on whether you've got it connected like this or if you swapped them, it would be the other way. And then you can kind of figure out for you what is clockwise and what is counterclockwise. Okay, so that is absolutely pretty straightforward. Let's come over here and let's see if I can let's just kind of compare this thing really quick, give you a second to get everything hooked up. But let me see if I can come and get one last look. Okay.
Yeah. All right. So what you can see here is you can see my schematic in this at the same time. And so you can see that this is hooked up just like this over here. And you can look at the schematic, you can look at the picture, and so with this you ought to be able to get this thing all the way hooked up just like we have it here.
So let's hop on over here and let's see if we can start coding, okay? And so how do we get this thing to turn on? Well, the one thing that you want to remember is, you want to come back over here to the sketch pad one more time. Okay, let's look at the sketch pad. What you want to remember is, there it is. Okay, what you want to remember is, that if we go low, low, it's off. If we go low, high, it's forward. If we go high, low, it's backwards. And what you also want to make sure is don't be going full blast forward and then just swap your highs and lows to immediately go full backwards. I like to go from forward to stop and then to backwards, or from backwards to stop then to forward. So I don't like to just switch the things all at once. I always end it with a turn the motor off and then turn it on to the direction that you want to go. Okay, I think that is what we need. Let me do a slight amount of Windows management here. What I will need you to do is go ahead and fire up a fresh new Arduino IDE. Okay. Can you guys hear that rain out there? Wow. The fishermen are off the river. They skedaddle usually pretty fast when the rains come in, because the rains can bring in some pretty big storms. And you can see it's looking a little rough out there. Take a look at the front yard. That's the corn patch out there, and this rain will be exactly what the corn needs, and so that'll be a big help. And you probably are going to start hearing the rain in the background because it is getting a little bit loud. But I have digressed. Did you guys catch last week's lesson with all the monkeys running across the compound? So yep, I do get easily distracted. But we're going to come over here and we're going to start coding this thing. Okay. So we have a fresh new bare minimum. And I need to set some variables up. You know, the other thing that I should tell you is, I'll tell you that in a minute. Okay, I will tell you that in a minute. So what I'm going to do is I'm going to set up my pins. So I've got BI for backwards input. That we're going to put to pin 10. That's how we hooked it up. And then int FI. Wow, that rain is really coming down out there. It's coming off the roof. We'll keep watching, see if anything develops out there. Here you don't see the rain so much, but it's really coming down out on that garden. Okay, so then FI, where did we connect that? We connected that to pin 9. Okay, like that. Now we come down to the void setup, and I'm going to do a serial.begin just in case I need to print something out. I'll go ahead and put that in there. I don't know if we'll use it or not. Now we're going to do our pin modes, and what was it? BI is going to be an output like that. and then pin mode. And that isn't pin modes, that's pin mode. And FI is going to be an output as well. Okay, so we've got our serial monitor turned on, we have our BI, and we have our FI set up. So that should be pretty good. Okay, now how do we turn this motor on? How do we turn this motor on? Well, what I'm going to do is I am going to do a digital write, and I'm going to go to FI, and I'm going to make it high. For forward is going to be high, and then digital write, and it's going to be BI is going to be low. Okay, just from that little table that we had over on our sketch pad like that. Now I am going to do a delay. I'll leave it on for a second, so a delay of 1000 milliseconds. And now I'm going to turn the motor off. And how am I going to turn the motor off? I'm going to get these two. I'm going to paste them. And I'm going to make it low, low. And then I'm going to wait for a second. So what should this do? This should turn the motor on for a second and then should turn the motor off for a second. I just got to look. It is really coming down out there. Really, really, really coming down. Okay. So now I'll turn it on for a second and then I will turn it off for a second. Now I am going to go ahead, and you guys always remember, charge this thing up. Don't try to do a motor experiment on a dead battery. So charge this thing up when it's charged. Now I'm going to come in and I'm going to go ahead and download my code. Okay. Now the motor isn't going to come on because I don't have any power to this yet, but let's go ahead and just see if it compiles. Okay. Boom! Look at that. So it's going very, very fast for a second and then off for a second. And you see it even it sort of coast for about a second. And that's why you wouldn't want to, man, it's really running to my wire there. Okay. You wouldn't want to have it off for a tenth of a second because you can see it's barely coming to a stop. It's coasting, it's winding down after the power goes off. Okay, so I'm going to go ahead and turn that off. Now what else could we do? Let's see if we can play around with the backwards direction. So to do that, I'm just going to take all of these lines of code here. I am going to copy them. I am going to paste them. And this time, in these last two, instead of going high, low, I'm going to go low on the forward. And I am going to go high on the backwards. Did I mess that up? Yeah, I put it wrong. That's the off one. Okay, so this one's going to go low and high. Okay, so this one forward is high, and then this one backwards is high. So it should go one way, and then it should reverse and go the other way. So let's go ahead and download this. I'm going to go ahead and turn the power back on. Okay, now let's watch it. And it is going to start counterclockwise, stop, clockwise, stop, counterclockwise, stop, clockwise, stop. Man, that thing is really running fast too. It's really, really running fast, much faster than when we were doing it with the transistor. You know, when we were working with the transistor, we had to lower the current because that S8050 transistor couldn't take the full current off the motor, and so we had to lower it, so we were not getting the speeds that we are getting today. Okay, now how about this? How about if we want to try to run at different speeds? Okay, so what I'm going to do is when I'm going high, instead of doing a digital write, I am going to do an analog write. And then what am I going to send it? I am going to send it MS for motor speed, and then down here, up here, where I have this one instead of high, I'm going to do an analog write. Now you could do digital write low. Instead of digital write low, you could do analog write 0, but since it's 0, I'm just going to do a low like that. But with analog write, then this, I need to give it a motor speed. If I'm going to use motor speed, I better declare it up here. So I'm going to have int ms for motor speed, like that. Okay, now I'm going to ask the user how fast he wants to run. So I'm going to what? To get input from the user, I need to do 3 things: ask, wait, and read. So let's ask, and I will say serial.println. What do I want to print? Please input motor speed, like that, and then clue them in that that is a number between, clue them in that that is a number between 0 and 256, like that. Okay, that looks good. Let's put our colon. So we do what? We ask, we wait. So I say while serial.available equals 0, and that needs to be in parentheses, I believe, like that. While serial.available equals 0, that means when there is nothing on the serial port, what do? Absolutely nothing. We have an empty clause. Now once there is something there, we want to read it. So I'm going to say ms for motor speed is equal to serial.parse int, that will read it in. And now I've got a motor speed, and I'm going to then write that motor speed to the motor. All right, does that look good? Could it really be that easy? Let's look and see. Okay, looks like we're compiling, and we are downloading. And let me turn on the serial monitor. Let me press the little reset button so it'll ask me again. So then what does it say? Please input motor speed. So let's start at 256 and just see what happens at 256. Nothing happened. What did I do wrong? Why is that not working? FIMS analog write. That one scared me. Power's not on. Okay, turn the power on and let's see if it works. Let's try it again. 256. Still not working. So what did we do wrong here? Okay, I am doing to FI, I'm doing MS. And then what is MS? MS is serial.parseInt. Wow. Do you guys see what I'm doing wrong here? Let's go back to digital write for this one. And let's just put it high. And let's see if that works. I just am a little curious why this isn't working. $256. Okay, so it goes forward and backwards. Okay, so let's... And then once it starts going backwards, it just kind of hangs there on the backwards. I wonder if okay. I'm wondering if I do an analog write, if I just need to make all of these analog writes. And the only thing I can think of is maybe it doesn't like me mixing analog and digital writes. I have never quite run into this before. Okay, so all those analog write lows need to be a 0. That's kind of peculiar. I've never... And then this needs to be motor speed. Okay, now let's see what's going to happen here. Okay, it is downloading. It's asking me for a speed. I'll say 256. It's going forward, stop, backwards, stop. Okay, now it's asking me for a speed again, so this time I'll say 100. Okay, do you see how it's going much slower? Okay, this time I will say go 50, like that. It's going forward very slowly, but it can start at 50. Watch this, you see it can start at 50, but it's barely starting. So let's see, what if we say 25 this time? 25? Can't quite start. Let's say if we said 35. Doesn't want to quite start. Well, sort of. Let's try 50 again. Okay, so what I'm kind of deciding is if what the sort of safe start speed is 50. So if you're going to want to start it, don't try to start it at 30. Start it at 50. The other thing you could do is start it at 255 and then quickly come down to a lower number to kind of give it a little bit of a kick. Okay. Wow, that rain is still coming down out there. Winds are kicking up too quite a bit. Okay. All right, I'm still confused. Did I do something that I'm just not thinking? Because I just never thought that there would be a problem mixing digital write and analog write. What if I go back here and put low, low? You know, I'm wondering, did I have some mistake in my code that I did not know about? We're just going to play around with this a little bit because I had it not working. Like that. Okay, now let's run it. So I turn those lows to digital writes, and let's see if it likes that. Okay, it's downloading, and let me turn it on to 100. It's going forwards, stopped. You know what it seems like is, it seems like that once I start doing analog writes on the pen, it doesn't like to go back and do digital writes. And I have never heard of that before, but that certainly seems like this analog write, this digital write is not making it happy. Analog, analog, And then let's go back to 0. Maybe a low can't turn. Maybe a low can't turn the PWM off. Once you go to PWM, maybe the analog right can't turn that off. That is about all that I can think. So analog right 0, analog right 0. Okay, let's see what happens here. I have an error. So I'm concluding once you go to analog rights, you better do analog rights and not try to go back to digital rights. Okay, so let's look at this and let's try a speed of 75. Okay, 75 forward, 75 backwards, second in between, and then let's go 125. Okay, faster forward, faster backwards. Okay, guys, I hope you are having as much fun taking these lessons as I am making them. I guess we're going to need a homework assignment. And so what the homework assignment that I want to give you is to be able to control this thing, instead of from the keyboard. What I want is I want a potentiometer, and you're going to read a value from the potentiometer, and based on what you read from the potentiometer, you turn this fan from off when it's all the way to the left to when you're all the way to the right, it's full speed. Okay, all the way to the left is off, all the way to the right is full speed. Then I want you to have a separate button, and that button is going to switch between forward direction and backwards direction. Now you can't assume that the user is going to be smart enough to turn the motor off before he switches directions. So when you switch directions, what you want to do is you want to first, if you're going forward, you want to number 1 stop, and then number 2 you want to reverse. And then if you're going in reverse and hit the button again, you want to number 1 stop, and then you want to number 2 go forward. So you don't want to have this thing running full speed and just try to switch from forward to backwards. Okay, so what does that mean? You're going to add a button and you're going to add a potentiometer. Okay, you're going to add a button and you're going to add a potentiometer, and then you are going to control the thing with speed and direction just from this without having to use the keyboard. Okay, guys, I hope you're having as much fun taking these classes as I am making them. As always, I want to give a shout out to you guys who are helping me out over at Patreon. Right now, it is my Patreon supporters that allow me to continue to produce fresh, great new content each week. Big thank you to you guys. Also, you can help me if you give the video a thumbs up and leave a comment down below. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you will get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.